People say the speed of light is the ultimate limit, as if that sentence already explains something. As if naming the thing that hits the ceiling tells you why there is a ceiling at all. And usually, without noticing it, they are imagining light as a particularly fast object, like a very good runner that just happens to win every race. That picture is comfortable because it lets everything else stay the same. Space is still space, time is still time, and light is just moving through it very quickly. But that picture is already doing a lot of hidden work, and most of it is wrong. If light were merely fast, then faster things would at least make sense as a question. You could ask what kind of engine you would need, or what kind of fuel, or what kind of clever trick. But the title doesn't say light is the fastest thing we've built. It says the speed of light is the limit. A limit is not a medal. A limit is something that breaks the rules you thought you were using. Notice how casually we attach the word speed here. Speed of what, measured how, compared to what else? Every speed you have ever measured involved clocks agreeing with each other and rulers agreeing with each other. You don't measure speed directly, you compare distances to times, and you quietly assume that distance and time are already settled ideas before the measurement begins. That assumption usually works so well that it becomes invisible. So when we say the speed of light is the ultimate limit, we are already assuming that space and time are sitting there, fixed and reliable, waiting for light to cross them. We are assuming the limit belongs to the traveler, not to the map. And that assumption feels so natural that questioning it sounds almost philosophical rather than practical. But here is the uncomfortable thought I want to leave hanging. What if the limit has nothing to do with light at all, and everything to do with the way space and time refuse to behave the way we expect once we try to push information too hard? Most people think they understand this because they can recite a number. They know how many meters per second it is, roughly, and they know it is large. But knowing a number is not the same thing as knowing what would fail if that number were different. If the limit were twice as big or 10 times smaller, what exactly would stop working? Would engines stall? Would atoms fall apart? Or would nothing obvious change at all? The fact that this question feels hard is already a warning sign. It means the understanding is thin, propped up by memory rather than structure. When a rule is truly understood, you know where it applies and where it snaps. Think about how you imagine motion. Something moves, time passes, distance accumulates. It feels straightforward because we picture a single clock ticking in the background, keeping score for everyone. That clock is so deeply built into our thinking that we rarely notice it is there. But ask yourself a simple question. How do you know two clocks far apart are ticking at the same rate? You cannot watch both at once. You must compare them somehow. And comparison means sending signals back and forth. Already, without saying it out loud, speed has entered the picture before we even talk about limits. Now consider this. Every statement you make about when something happens somewhere else depends on a message arriving. You never know an event as it happens at a distance. You know it when its influence reaches you. We talk as if time flows everywhere equally, but operationally, all we ever have are arrivals of information. This is not philosophy. It is a description of what actually occurs when measurements are made. The idea of a universal now is something we add after the fact. This is where people usually say, fine, signals take time, but that's just a practical issue. That response assumes the delay is a nuisance layered on top of an otherwise clean picture. But suppose it is not a layer. Suppose it is the picture. Suppose time and distance only mean what they do because signals behave the way they do. Then the question shifts. The issue is no longer how fast light moves through space, but how space and time are stitched together by the way information propagates. At this point, confusion should start to build, and it should not be rushed away, because something else is quietly failing in the background. Different observers, moving relative to one another, do not agree on distances and times in the way you expect. Not because their rulers are bent or their clocks are broken, but because the method they use to coordinate those rulers and clocks depends on signal exchange. And if those signals behave in a very particular stubborn way, agreement itself becomes conditional. So now we are stuck with an unresolved tension. Either space and time are absolute, and signals are merely slow messengers within them, or signals define what space and time can consistently mean. We are not allowed to choose yet. But notice how far we have moved without talking about light as a glowing thing at all. And notice how the original belief that the limit is about a fast traveler has begun to feel less secure, even though nothing dramatic has happened. There is a moment here where people usually reach for a familiar word to steady themselves. They say something like reference frame or relative motion, as if naming it settles it. But naming is exactly what we are trying not to do. What matters is behavior. What actually happens when two observers, moving differently, try to agree on what occurred and when. Imagine two people far apart, drifting past one another, each with their own clock. They want to say whether two distant events happened at the same time. There is only one way to do this: exchange signals and compare arrivals. There is no shortcut, no direct access. Every method reduces to waiting for something to come to you. And the strange part is that the procedure works the same way for both observers, yet it does not give the same answers. This is where intuition quietly collapses. You expect disagreement to come from error, from noise, from imperfect instruments. But here the disagreement is systematic. It is built into the method itself. Each observer follows the same rules, uses the same logic, and still ends up with a different ordering of events. Not approximately different, fundamentally different. If that sounds like a paradox, it's because something familiar is being asked to do a job it was never tested for. We assumed that "at the same time" was a universal label, something you could attach to events independent of who was doing the labeling. But the act of labeling requires coordination, and coordination requires signals, and signals do not arrive instantaneously. The delay is not an error to be corrected. It is the mechanism. Now here is where the speed limit begins to show its teeth, without being named. If signals could arrive arbitrarily fast, then coordination would collapse back into a single shared picture. Everyone could agree. The idea of a universal time would quietly reassert itself. But if signals have a stubborn, observer-independent pace, then coordination becomes observer-dependent. Agreement becomes local, not global. We are not yet saying that space shrinks or time stretches. Those are conclusions, and conclusions come later. Right now, we are only watching a constraint tighten. We are seeing that the structure of agreement depends on how fast influence can travel. And if that speed refuses to budge no matter how you move, then something else must. The unresolved question is this: when observers disagree about time itself, what exactly is reality refusing to give them for free? Up to now, we have avoided saying what usually gets said first. We have not talked about engines or particles or energy limits. That omission is deliberate, because the trouble shows up before any machinery is built. It shows up the moment you insist that cause must come before effect for everyone, not just for you. That sounds so obvious that it barely registers as an assumption. But try to imagine giving it up. Try to imagine a world where one observer sees an effect before its cause, while another sees the opposite, and both are equally correct. You can say the words, but you cannot run the world that way for long. Prediction collapses. Explanation collapses. You no longer know what it means to influence anything. So we quietly demand consistency. We demand that if one event can affect another, that order cannot flip just because someone is moving differently. That demand is not philosophical. It is practical. It is the minimum requirement for talking about causes at all. And once you demand it, a boundary appears. Not because we drew it, but because without it, the entire structure of explanation falls apart. We have not yet said what sets the boundary's value, only that some boundary must exist if cause and effect are to survive intact. This is where people often imagine adding speeds. If something moves at one pace and you chase it, you expect to close the gap by adding your motion to its motion. That rule works beautifully at low speeds, which is why it feels like a law rather than a habit. But it was never tested where the boundary lives. It was assumed, and assumptions have a way of becoming invisible until they fail. Suppose you try to add speeds anyway, past the boundary that keeps cause in order. What happens is not that objects protest or engines refuse. What happens is that the bookkeeping breaks. Different observers, using the same rules, start disagreeing about which events can influence which others. The math does not explode. The interpretation does. You are left with equations that predict outcomes you cannot consistently describe. Now we can talk about the thing that forced our hand. There exists something in nature whose observed pace does not change when you chase it or flee from it. This is not a belief. It is an observation repeated in every viable experiment we know how to perform. Call it light if you like, but the name is incidental. What matters is the behavior. Everyone measures the same pace, even when everyone is moving. Hold that without resolving it, because it sounds impossible if you keep the old picture of space and time intact. If speeds add, this cannot happen. So one of those ideas has to give. Either measurement is lying in a coordinated way, or space and time are not doing what we thought they were doing. There is no third option that preserves consistency. The temptation is to say space shrinks and time stretches, as if those phrases explain something. But those are labels, not mechanisms. What actually happens is more restrained. The rules that convert signal arrivals into distances and durations adjust themselves so that the boundary is never crossed. Not sometimes. Always. This is not enforced by force. It is enforced by structure. The way measurements fit together leaves no room to cheat. At this stage, light has almost disappeared again. It is not acting as a speed champion. It is acting as a reference behavior. It reveals the limit because it is not slowed down by mass or structure. It has nothing to negotiate with. Anything else, carrying baggage, ends up slower. Not because it tries and fails, but because trying already assumes the very framework that contains the limit. And now the interpretation narrows. The limit is not about difficulty. It is not about technology. It is not about insufficient cleverness. It is about the fact that reality allows only so much disagreement before it stops being a single reality at all. The limit is the price paid for a shared order of events across different states of motion. What remains unsettled is the deepest part. We can see what would break without the limit. We can see how measurements rearrange themselves to protect it. We can even see why light happens to sit exactly on the boundary. But we are still left with a quiet question that does not go away. Why does the universe choose to preserve causal order this way, instead of allowing something looser, stranger, or more permissive? We know what happens. We know how we know. But the necessity itself is still sitting there, unexplained, waiting for someone to stop being satisfied with names. At this point, it is tempting to feel as if the mystery is nearly solved. The pieces line up. The boundary preserves order. Measurement adapts. Reality stays consistent. And yet that sense of completion is misleading because it sneaks in another assumption that has not been examined. We are assuming that the boundary is something imposed on the universe, like a rule written on top of otherwise free behavior. But nothing we have described so far behaves like an imposed rule. It behaves like a consequence. Notice what has not appeared anywhere in the reasoning. There is no mention of resistance, no medium pushing back, no exhaustion of energy. Nothing is straining. Nothing is stopping anything. Instead, every attempt to describe influence beyond the boundary dissolves into contradiction. Not physical contradiction, but logical contradiction. Statements stop fitting together. The map stops being drawable. That should bother you in a very specific way, because it suggests the limit is not a wall you crash into, but a condition for having a coherent description at all. You are free to imagine signals faster than the boundary. But the moment you try to describe what different observers would see, the description fractures. The problem is not that the universe forbids it. The problem is that the idea cannot be made consistent with the requirement that observers share a single network of cause and effect. This is where many explanations quietly smuggle in authority. They say, nature says no, or the law forbids it, as if that ends the matter. But laws are summaries of behavior, not explanations of necessity. The necessity here comes from something weaker and stronger at the same time. We are insisting that events can be arranged into a structure that everyone, regardless of motion, can agree is not self-contradictory. So the limit survives not because it is protected, but because without it, the concept of protection, influence, or sequence loses meaning. That reframes the original belief entirely. The speed in question is not a property something has. It is a property the universe must respect to remain intelligible. And the unresolved edge is still sharp. Intelligible to whom and by what deeper requirement? Once you see the limit this way, another quiet mistake becomes harder to ignore. We tend to think that the universe owes us an explanation in terms we already like. Space here, time there, things moving through both. But what we have actually been doing is the reverse. We have been carving space and time out of the behavior of signals, not watching signals move through pre-existing containers. The containers are the abstraction, not the foundation. This flips the usual sense of dependence. Instead of asking how fast something travels through space, we are forced to ask how space itself is inferred from the exchange of influence. Distance becomes a story told after signals arrive. Duration becomes a comparison between cycles of clocks that were never truly independent. That is why the boundary shows up everywhere at once. It is not inserted. It emerges wherever consistency is demanded. This also explains why the limit does not care what carries the influence. Light happens to reveal it cleanly because it strips the situation down to the bare minimum. No rest, no mass, no internal clock you can slow down by shaking it. But if something else behaved the same way, it would expose the same structure. The boundary is loyal to structure, not to substance. There is an uneasiness here that should not be smoothed over. If space and time are not primary, then asking why the limit has the value it does starts to sound like asking why logic has the shape it has. You can describe the consequences of changing it, but description is not derivation. You can say what would break, but not why this particular arrangement exists, rather than another consistent one. So we end up in a narrow but honest position. The speed we talk about is not chosen, not tuned, not optimized. It is simply the speed that falls out when you insist that influence, order, and observation fit together without contradiction. That tells us a great deal about how the world behaves. It tells us almost nothing about why this is the only way it could have been. And that remaining gap is not a failure of explanation. It is the boundary between understanding behavior and explaining necessity, a boundary that so far refuses to move. There is a danger, right at the end, of thinking we have replaced one simple picture with another and are done. We started with light as a fast thing, and now we have a limit as a structural requirement. That feels like progress, and it is, but it can also hide how strange the situation actually is. Because we have not discovered a mechanism, we have discovered a constraint on what mechanisms are allowed to mean. Think about how unusual that is. In most areas of physics, when something cannot happen, you can point to a process that fails. Friction heats things up. Materials break. Energy runs out. Here, none of that appears. You can write equations for faster influence. You can imagine devices, nothing jams. What fails is the ability to tell a consistent story that everyone can agree on. The universe does not push back. It simply stops making sense. That should force a pause, because sense-making is something we usually assume is our problem, not the universe's. We imagine that reality is doing whatever it does, and we are the ones struggling to describe it. But here, the description and the behavior are inseparable. The demand that causes precede effects for all observers is not an extra preference. It is the condition under which the idea of effect survives at all. This also explains a subtle asymmetry that often goes unnoticed. We can imagine many different kinds of particles, many different forces, many different interactions, but we cannot imagine many different kinds of time. The moment time becomes something that flips order, depending on who is watching, it stops functioning as time in the ordinary sense. The boundary protects that ordinary sense, not because it is comfortable, but because without it there is no stable notion of influence to work with. Notice how this reframes the usual question people ask. They ask why nothing can go faster than light, as if light were the reference. But the real question is why influence has a maximum pace at all. And the answer is not because experiments say so, even though they do. The deeper answer is that without a maximum pace, the structure that lets experiments be compared collapses. Agreement itself becomes optional. You might try to escape this by allowing influence to go faster while keeping order intact by some clever rule. But any such rule has to be shared by all observers. The moment it privileges one state of motion over another, you have reintroduced a hidden universal clock or a preferred frame, which is just another way of smuggling in what the limit was already doing cleanly. The escape routes circle back to the same place. There is also a quiet reason why the limit feels so abstract compared to other constraints. It is not tied to matter. It does not weaken or strengthen. It does not care about scale. The same structure governs atoms, stars, and empty space. That universality is a clue. It suggests we are not dealing with a property of things, but a property of relationships between events. The universe is policing the coherence of those relationships, not the speed of any particular object. This is why saying space and time mix is true, but unsatisfying. Mixing is what you see after the fact, once the constraint has done its work. What matters is that the bookkeeping rules for events adapt themselves so that no observer can send influence in a way that unravels causal order. The adaptation is automatic. No negotiation is required. The rules simply leave no other option. At this point, light has become almost irrelevant again, except as a reminder. It is the cleanest signal we know, the one that carries influence without internal delay. It reveals the boundary the way a perfectly straight edge reveals the shape of a surface. But the surface was already there. The edge did not create it. If this feels unsatisfying, it should. Because we have learned something precise about how reality behaves, but we have not learned why this structure is the one that exists. We can imagine other logical systems. We can write down alternative rules. Some of them are internally consistent on paper. What we cannot do is connect them to a world where observers exchange information and agree on outcomes without contradiction. That narrowing is empirical, but the pressure behind it feels deeper than measurement. So the final position is an uncomfortable one. The speed of light is not the ultimate limit because light is special. It is the ultimate limit because without such a limit, the idea of a shared physical world loses its footing. That tells us how far explanation can go using observation and logic alone. What it does not tell us is why the universe insists on being shareable in this particular way, rather than some other way that we have not yet learned how to inhabit. And that question remains open, not because we lack cleverness, but because we may be pressing against the edge where describing behavior stops and justifying necessity begins. There is one last assumption hiding underneath everything we have said, and it is easy to miss because it feels harmless. We assume that the universe must be understandable in a single, consistent way by all observers. We never proved that. We simply refused to let go of it. Every step of the reasoning leans on that refusal. The limit survives because we insist on shared order, shared explanation, shared causality. If that insistence were relaxed, the structure could dissolve without contradiction, just without coherence. The speed limit is where our demand for a common reality quietly becomes non-negotiable.